Welcome to class, student. Today we are talking about afflictions and flying balls. And we are at the baseball field, and we want to see what happened if we change the elevations, if we change the angle, if we change the speed, as we covered earlier on in our lesson that I told you to focus on elevation, speed, and angle. So those three things can be manipulated in this lesson. So the first one we'll try to focus on will be elevations. So we will go ahead and start with the lowest elevations and keep the same angle and keep the same speed to see what happened if we switch between elevations. So let's go ahead and get started on elevation. So if we change the elevation to New York and hit clear, and let's start with at the 45-degree angle with the 100 miles an hour speed, and we hit the ball. So this is where you notice that the feet the ball travel is about 310 feet. To not being a baseball player, I think this is pretty good. But if I want to hit the ball out of the park, where would be a good elevations that I want to play? Where I want to play elevation that is very low in this scenario, which would be the New York elevations, or would I want to play at elevation that is very high? So if I change the elevation to the very highest elevations and I keep the same angle and the same speed, what happens? So now I can hit the ball about 376 feet, which is pretty good. If I'm a hitter, this is where I want to be. This is the place I want to play because I know if I receive the ball at this 45-degree angle and 100 miles an hour speed, it gives me a good chance to get a home run. Now, what if I'm playing in Denver and the elevation it's 5,183 and I keep the same angle and the same speed? What happened? So when I play in Denver, the lower I goes on the elevations, the lower feet I can hit with the same angle. So I remember earlier with the higher elevations, we hit about 376 feet. With the lower elevations, we hit about 297. Now with Denver elevations, we hit 333 feet. So as a baseball player, if I'm a hitter, the best place to play if I receive the angle at the 45-degree angle and 100 miles an hour speed would be at the higher elevation because you get more chance to get a home run and hit better. But what if I'm a pitcher? What happens to the elevations? Let's go ahead and keep this and change the angle. Let's go ahead and change the angle to 60-degree angle and just keep the same speed and go through the elevations and see. Let's start with New York to be frank. So if I'm a pitcher, maybe New York at the lowest elevation might be a good place to play, depending on the team I'm playing against, the hitter. But as a pitcher, I think New York would be a good place to play. But now, what if we have elevation that is Toronto, which is 247 with the same angle? What happens? So we pretty much get, so if you play in Toronto and you play in New York with the same elevation, well, the both of them doesn't have the same elevations, but both of them have the same height. So in New York with the elevation of 55 and in Toronto with the elevation of 247 and the same angle and same speed, we get the same feet, which is 282. So for some reason, those two plays as a pitcher would be a good place for me because I can pitch the ball and I have the opportunity of catching the ball because my teammates can move faster and catch the ball because it spends a lot of time in the air based on the elevation. So if we go to an elevation that is a little bit higher, places like St. Louis, where the elevation is 470 feet with the same angle, and I hit the ball, so there's no one difference. There's no one difference. There's no one feet that is different. When I was playing in New York, when I was playing in Toronto, at the same angle, at the same speed, when I play in Toronto, the same speed was 100 and the hit was 282. And when I play in St. Louis, it's 283. So as a pitcher and as a hitter, this is a disadvantage for me because I don't want to, even though the elevation is changing, but my hit still doesn't improve that much. So if this was in the higher elevations, 593, I want to see what would be the difference. Well, pretty much you get 1 feet different if you were playing in Milwaukee. If you're playing in Kansas, which is 750 elevations with the same speed, basically it's the same thing. Because if I'm a pitcher, this would be a place I want to play. But if I move to Atlanta as a pitcher, what would be the difference? To be honest, the higher elevation with the 55-degree angle, 100 miles an hour speed, nothing changed that much. But let's move to Denver and see what happens. Now, as we start to go up in the elevations, hitting in Denver, I move up to 303 feet. With the higher elevations, this move up to a lot better. So the higher elevations, which is 14,109 high elevations, and the angle is 55-degree angle and 100 miles an hour speed, I think is the best place to play. But what if I want to hit it out of the park and I'm a pitcher and I'm a hitter and I playing at what angle should I receive the ball? So if I receive at a 35-degree angle, this would be good. But what if I want to hit at 400? What angle should I change? If I change at the 30-degree angle, stay at the same place, at the same elevations. Okay, what if I change, I hit clear? Now, as we change things around, one thing I also want you to understand that you should also think into a real life scenario that how can I use this? How can I use this if I'm playing, let's say, if I'm not playing baseball, if I'm playing soccer, if I'm at the higher elevations, I'm going to burn a lot of energy because compared to a lower elevation when it comes to soccer, when it comes to baseball, when you're at the higher elevations, the ball travels a lot faster at the higher elevations compared to a lower elevation. For example, if I was using this higher elevations and the degree was 35-degree angle with the same speed in the very high elevations, okay, so the ball doesn't spend that much time in the air on the higher elevations. But if I move to the lower, because you can see the arc of the line, that the ball at the higher elevation does not spend a lot of time in the air. It's very easy, gravity pulls it back on Earth, so it's a lot easy. But compared to the lower elevation, which would be New York, and the same angle and the same speed, the ball even spent lesser time in the air. Well, let's just go down the elevations and see what happens. So it basically at the same speed. But what if I change the angle to, let's say, 50-degree angle and increase the speed to the highest as we can? Well, it feels a lot better to play in Toronto at an angle of 55-degree angle and a 135 speed because you can hit the ball at 396 feet. So what do you think comes to your mind when you hear the word elevations, when you hear the word angle, when you hear the word speed, because as a pitcher, those are two things that you want to keep in your mind to say, where can I play? Can I play in Kansas City? Is it better for me as a pitcher to play in Kansas City? Or is it better for me as a hitter to play in Milwaukee? These are some things you want to think about to say, even apart from baseball, when it comes to driving, does the car travel faster on the higher elevations, or do I need more gas for the car to travel on the higher elevations? Or do I need less gas based on the pedal? If I push the pedal, do I need to push the pedal a lot harder to go faster on the higher elevation? Or do I need to let go of the gas based on a lower elevation? This is something that we can also think about as we move on. So the next part will be just come up with a scenario that you can think about. It might, let's come up with three scenarios. The first one should be about baseball, and the second one should be about a different sports or a real life scenario that you can use the same speed or maybe angle and the elevation. Like I mentioned earlier, if I live in a city that is on the high elevations, I want to say I think the car going to travel a lot faster, I mean a lot slower compared to if I live in a city that is a lower elevation. Because the elevations kind of tells you how high is the ball going compared to baseball. So if you live in a city that is a very high elevations, you have to, if you're a runner, for example, if you're a runner, you have to adjust. If you move, this would be a real life example. If I run track and I live in places like New York, which have the elevations of 55, and I'm running in Denver, which have the elevation of 5,183, that's a huge change. That's something that I need to adjust to because the amount of time that it's going to take me to breathe, it won't be the same because I'm used to running at the elevation of 55 elevations compared to running at a different elevation in Denver. So that's something I need to either go there ahead of time to practice, to understand what I need to work on, how fast I need to move, because the elevations can change things. And as we see in this scenario, in this lesson, the elevation plays a huge part. The angle might change a little bit here and there, but the elevation is what really matters because elevation tells you how high is the ball going to stay in the air. Is it going to come down quicker or is it going to come down faster based on elevations? So as we move forward, just start to think and see what you can come up with. So I will need three real life scenario that you can use this class lesson and transfer to compare to distance and values and difference combinations. So this is something I want you to think about. To say, can I use speed and elevation together, or can I use angle and elevation? You don't have to use all three of them, but you can choose to use one of them. So I will end my lesson here for today, and please ask any questions if you need to. And like I said, so I want to hear reflections, and I want to know what worked best for you when you tried this lesson. If you go ahead and change the speed and change the angle and change the elevation, what happened? Because I just played with a few of them to see what I can get to give you a good understanding of elevation, speed, and angle. And you can clear at any time. For example, if you make a mistake, let's say if I want to be at Atlanta and I want to hit at a very low, a 0 degree, which doesn't really happen that much. But just for example, if I want to hit at a 0 degree angle and so it doesn't really work. What if I increase the angle? Okay, this is very low. So if I want to hit the ball, as a pitcher, this is something I also want to think about. At the higher elevations, I want to receive the ball at a very low angle. If I'm on the higher elevations, if I'm on the lower elevations with a 10-degree angle, it's basically the same thing, the same feat. So I hope you have learned something from this lesson. Please ask questions if you need to, and please email me if there's anything I need to cover for the next lesson before we move on. Thank you, class. Have a nice weekend.